Okay, good morning, everybody. Today we're going to be talking again about the first derivative test. But before we get there, we need to define some things about maximums and minimums to help us complete the derivative test today. So something that we have to consider is, let's say any function f of x that is continuous. All right, that means it has zero discontinuities. We're not talking about vertical asymptotes or that kind of sign test. We're just trying to figure out maximums, minimums, and basically critical points and what they look like. So we talked about critical points and how to define them. And we talked about basically taking the derivative and seeing what that was going to be equal to. But once we find that, f of x is going to be a maximum if f prime changes from a positive to negative. Okay, and just a quick sketch of that. If you think about this, f prime once again is talking about the slope. So I'm going to make that annotation here. Okay, and then we might use words like increasing and decreasing. So for something like this, if it goes from positive to negative, it's going to be going up, and then it's going to be going back down afterwards. And with normal functions and curves, it's going to be rounded, kind of looking like a parabola. F of x is going to have a minimum. Let's see, that would have to be getting to the bottom. So in this case, we're going to be talking about if f prime, the slope changes from negative to positive. All right, so once again, what that looks like is, once again, this is talking about the slope. So slope is going to be going down, it's going to be decreasing, and then it's going to be increasing. Somewhere in the middle there, it has to change, and when it changes, that's going to give us our minimum. Now, if f of x doesn't change, well, there's going to be no extrema. So we would say in this case, f of x, f prime, does not change. So if we look at the slope and it goes from positive to negative, it's going to reach a maximum at that point. And just think about what that sketch looks like. Or you can refer back to just what the derivative does, right? But if you think about this one, if we just go from positive to positive, all right, it's increasing. It might level out and increase again. And in something like that, even though that there is a horizontal tangent there isn't a maximum or minimum. As you can see, that point right there is neither the highest around nor the lowest around, but it does have a zero as its derivative. So that's what it would look like if it had zero change. So we would just kind of say no extrema for something like that. No extrema at a if that happens. So let's look at some examples, and let's actually do the first derivative test with those examples and figure out if they have maximums and minimums. So for each of the next two examples, here's what we are going to have to do. We are going to identify the x values of the critical points in the following functions, then classify the value as a maximum, minimum, or neither. Okay, so we are going to be identifying just the x values. That's important for us. And of the critical points, if I think about critical points, that reminds me that the derivative needs to be equal to 0, right? That's from the previous 2 days of the following functions. Then classify as max, min, or neither. So when I do this, I have to be looking at the derivatives, right? To see what the derivatives are doing. So the very first example is f of x equals 1 minus 6x plus x squared. So we need to find the slopes to know if it's a max or min. So to find that slope, if you remember from last week, the first step was to take the derivative. So the derivative of a constant is 0, minus 6x just becomes negative 6, and plus x squared, remember we move that down to become plus 2x to the first. After we do that, we are going to set equal to 0. That's going to find us all horizontal tangents, and then from there we are just going to solve. Now normally we would have to factor to solve, but this is just a linear equation, so we can add 6 to both sides and then divide by 2. And we'd get something like x equals 3. That is our only solution for this problem. So once we take that solution, we are going to create a number line. And this is just a great visual, and this is going to help us sketch what's happening. So on our number line, all we know right now is 3. Okay, something is happening at 3. Really, that's the only thing that we have to consider in this entire problem. So just getting a picture of what that looks like is important. So remember from last week, after we create that number line, we are just going to plug in numbers to find slope. I would say in each interval. Well, in this case, we only have 2 intervals. We have negative infinity to 3 and 3 to infinity. So in that case, there's really only a couple of things that we would have to plug in. So let's say anything to the left of 3 would help us find our slope over here. So let's just think what's smaller than 3. I would say a number like, I don't know, 2. And we're going to plug into the right, let's say a number bigger than 3, let's say 4. And we are going to plug those into our derivative. I'm going to put a star next to that derivative right here in order to find out what their slope was in that case. So we're going to plug in, let's find f prime of 2 equals negative 6 plus 2 times 2. And we're just going to do the math here. And remember, we don't have to actually solve this entire problem. We just have to know the sign. But in this case, it looks like we might have to do the whole work. Let's see, negative 6 plus 4 equals negative 2. So that tells me that to the left of 3, we have a negative slope. Now let's find to the right of 3. Now that right away, that could be telling me it's going down. It might be a minimum, right? It's going down, it might be a minimum, or it might be going down, level off, and go down again. So I'm kind of down to these 2 examples right here if it starts off as decreasing. But let's see what happens as it goes to the right. So as we get past 3, let's say at 4, we're going to plug that into the same point, or the same derivative formula. And we would get negative 6 plus 8, which is positive 2. So we'd see that it definitely does change from a negative to a positive. Well, it's important to, if you don't know what this looks like, it's important to sketch it. So what would this look like if it goes from a negative, it's going down, to a positive, going up? And we know that the slope is 0, so it is going to level off there. So it's looking something like this in this case. And we have to justify if that was a maximum, a minimum, or a neither. So we found the x value, and at x equals 3, we have, let's say, instead of we have, let's say f of x has a minimum because f prime of x changes from negative to positive at x equals 3. Now, if I wanted to go a little bit extra, I could say not only is that changing from negative to positive, that slope, but it's also continuous, and that it also has a derivative of 0 at 3, right? We know that it's not like a discontinuity, it's not a vertical asymptote of any kind. And there's our answer. So just like what we were doing before, but really adding in that sketch is super important. And this is what I'd be looking for when I'm looking for you guys doing your work on the homework, on the classwork, whatever we're going to practice today. Okay, another example is going to be g of x equals 3x to the 5th minus 5x to the 3rd plus 15. So we're going to go through the same process here. Just find the x values of the critical points and identify maximum minimums or no extrema, in this case, or neither. So the very first thing that we're going to do is we're going to take the derivative using the power rule. 15x squared minus, let's see, that's going to give me 15, I'm sorry, that's x to the 4th, pardon me. This is going to be x squared and that 15 is going to be just turning into a constant. So now from here, we're going to follow the same steps as above. So if you get stuck, you can just refer to those steps above, but we're going to set this equal to 0 to find out where we're going to get any horizontal tangents, where it kind of levels off. That might be a maximum or a minimum. It might be. And then from there, we're going to solve by factoring. So here, it actually looks like we can take out a GCF of 15 and an x squared. So we're going to do that. And then whatever I have left, that's just going to be x squared remaining. And then nothing really remains there, so if I divide that by itself, I get 1. X squared minus 1. All right, then from there, I've actually have it solved. So to solve this, or factors, so to solve this the rest of the way, we can continue to look to factor here. And what I have is an x plus 1 and an x minus 1. Remember that is just a difference of perfect squares. So now we can actually find all of our critical points. We're going to have 3 of them. We are going to have, let's see, 15x squared equals 0, and x plus 1 equals 0, and x minus 1 equals 0. So solving those really quickly, if I divide by 15 and then square root that, I'm still going to get 0 here. I'm going to get negative 1 here, and I'm going to get a positive 1 here. So those are my critical points. Those are the points in question. So now from here, we have to put those on a number line and just see what those are doing. Are those changing from positive to negative, etc.? So let's look at our number line. We have a 0. Oops, I have this backwards. I should start with negative 1. Negative 1, 0, 1. Now, these are the numbers. Now we have to actually figure out what numbers we should plug in to find the slope. So we know that the slope is going to be 0 at all these places. So those are the points within question, and now we have to figure out what is happening in those intermittent ranges. So what's happening in each range? So we have to pick out a number in each case. So think about what is to the left of negative 2. Well, negative 1. I'm going to plug in negative 2. So off to the side, let's actually find f prime of negative 2. And let's see, I'm going to put a star next to my formula that I'm going to be using. And I actually could use this one instead, or I could use this one instead. It's really up to you. I'm going to use the last one because it's already factored. That's going to be the easiest way to use my sign test. So 15 times negative 2 squared, and then we're going to plug in a negative 2 for each x. And this is where it's nice that I'm using the factored form. I now only have to find the signs of each product and actually find out the sign of my answer. So in this case, think about what is a negative times a negative. Well, that's going to be a positive. So this whole thing is going to be positive here. A negative, and well, see, the negative has a greater absolute value, so that's going to be a negative. Negative 2 minus 1, that's going to stay a negative. And now when we have the product of two negatives, that's going to turn into a positive. So our entire answer there is just going to be a positive. It's going to be increasing from negative infinity to negative 1 because our derivative was positive. Now let's find the derivative of some number between negative 1 and 0. Well, we're going to have to use a decimal here. Let's call it negative 0.5. Now before you kind of freak out because we're using a negative, remember that we just have to know what the sign is going to be. So I'm still going to use the same exact derivative, the factored form, that is going to be the easiest form. And I'm just going to find the sign of all my products here. So once again, if I'm squaring something, I'm going to have a negative times a negative. That's going to stay a positive, so that whole first term is going to be positive. And now, actually 1 is bigger than 0.5, so that stays a positive in that product, or that sum. And then here I have a negative minus 1. I'm going to go further left, that's going to stay negative. So now with products, only two negatives would make a positive, so this is going to stay a negative. So I have a negative slope in here. And now I'm going to do the same thing with a positive 0.5 and find the slope there. So find the slope at 0.5, and I'm going to do this one really quickly. Let's see, a positive times a positive is a positive, so that's all going to be positive there. 0.5 plus 1, that's going to be positive there. and 0.5 minus 1, that's going to be negative there. So that one's going to stay negative. And then lastly, we're going to have to take something larger than 1, so let's say 2. So in this case, once again, let's call that 2 squared. And then 2 plus 1, 2 minus 1. That's going to be positive, positive, and positive. So it's positive. Okay, so now we have to identify what is happening here. I know my slopes in each case, so maybe drawing a sketch either off to the side or down below would be a great thing to do. So it's going to be going up, then it's going to be going down. Then it continues to go down. Notice how the slope doesn't actually change there. And then the slope goes back up to increasing. So which one of these are going to be extrema? Well, let's see. Right here, it's actually going to be getting to a high point. Here, it's going to level off, not going to be the highest or the lowest, right? It's actually changing or staying from negative to negative. But then somewhere in here, it has to go from negative to positive. So the only extremas are when it changes the sign of the slope, goes from increasing to decreasing or decreasing to increasing. So we have a maximum at x equals negative 1. We have a min at x equals positive 1. And if you want your justification, I'm going to have you look up all the way to the beginning of your notes to talk about what the derivative is. Okay, I'll see you guys in class. Love you, miss you. See you later.